So recall that another concept that we studied last time was this idea of using the present values to come up with a capital budgeting rule. So capital budgeting rules tell us whether to take up a project or to reject a project. And we had used what is known as the net present value as an example to come up with this decision. So this week we are going to be seeing other examples of capital budgeting rules as well. Of course, none of them probably are as good as net present value, but they are also quite frequently used. So we need to be aware of them. And we'll be seeing how net present value comes up in comparison to them, right? So before we get into that, let's just kind of like recap what was the notion of net present value, and let's look into a few more details about this concept of net present value. So throughout our discussion, we are going to be assuming whatever we had assumed last time, so perfect markets, and on top of that, we are going to assume that there are interest rates which are constant throughout, and then there is no uncertainty. So these are assumptions that we'll discuss later on and relax them as well, but that will take some time. So we first want to understand what are the implications of this assumption, and we'll relax them one at a time, and we'll see what we get as a result. Okay. So how did we use NPV to decide whether to take up a project or not? So the basic procedure was very simple. What we have to do is we have got cash flows, which may be inflows or outflows, which are occurring at different points in time. And what we want to do is we want to convert them into the same units, which is money today, using the concept of present value. And once we do that, we can actually add up all the cash flows, right? The present value of all the cash flows. And basically, we'll take up projects which have a positive NPV, and we'll reject projects which have a negative NPV. So this was the NPV capital budgeting rule. So let's make sure that we understand why is the NPV a good rule to use, right? So in a perfect market where you have got perfect information, a positive NPV project is actually the equivalent of free money. Okay. So let's take an example to understand why this is the case. So suppose that you are in an economy where you can borrow or lend money at a rate of 6% per year. Okay. And you have in your hand an opportunity to invest in a project that costs 1 unit today, but is going to give out 1.07 units next year, right? So that the rate of return for this project is 7%. Now, if you do have access to this project, this is actually going to lead you to getting 0.01 units next year for free. In case you are thinking this is a small unit, well, I didn't tell you what the units are, right? So units may be in crores, millions, and so on. So then it's 0.01 crores, millions, and so on, right? Let's see why is it the case that you are getting this money for free, or how can you get the money for free? So remember, you can actually borrow money at 6% per year, right? So imagine that you had initially no money available to you to finance this 1 unit of project, but you can borrow money, right? So that is the assumption that is here. So if you borrow 1 unit of money today at 6%, what it means is that you have to pay out 1.06 next year, right? But you can borrow this 1 unit and actually invest in this project, and this project is actually going to give you 1.07 units next year. So out of the 1.07 units that you have got next year, you can actually use that to pay back this 1.06 units that you owe, because you have to pay the interest on the money that you had borrowed, but you get to keep the remaining 0.01 units in your pocket, right? So just by being able to borrow and lend at this rate, which is lower than the rate of return for this project, you are able to make money for free, right? Okay. What about the other case? So suppose that actually you have access to a kind of like a project where you can actually sell someone, okay, an investment opportunity for 1 units, which yields only 1.05 units next year. So we are not going to get in the question of why somebody would be interested in buying, but let's just imagine that you do have someone who is willing to buy this thing, right? Okay. So in this case also, you can actually make money. How will you make money? So here, basically what will happen is that you will sell somebody this investment opportunity for 1 unit. Then you will put this 1 unit and you can kind of lend this money out at 6% per year. So next year, you are going to have 1.06 units of money, right? And you have to give this person next year to whom you had sold this investment opportunity only 1.05 units back, right? So again, you can give back this person 0.5 units, and you can get to keep this remaining 0.01 units in your pocket. So again, you end up getting 0.01 units for free, right? So what that tells you is that basically only zero NPV projects. So in this particular economy, where for 1 unit cost, you are getting a 1.06 payoff, that's the only one that does not allow one to earn free money, right? And in a perfect world, okay, if one has all the correct inputs, which is the cash flows and the interest rates, right? NPV is actually the appropriate decision benchmark, right? So this is the best that you can do if you have access to all the correct inputs. Then this is the only thing that you require, right? So information other than this NPV is completely redundant in terms of deciding whether to take up a project or not. Okay. Now, of course, in a perfect world with no uncertainty, positive NPV projects are going to be rare, right? Why is that the case? Because as we have argued, if you have a positive NPV project, this is equivalent to getting money for free, right? So you can very easily kind of like in this perfect world, basically either borrow or lend money and then basically use that money to kind of like use this project to get rich, right? So everybody can also do the same thing, right? And everybody would want to take them up. So there's going to be higher demand for these NPV projects. And as a result of that, price of these projects are going to go up. So the economy would adjust and the rates of return are going to be bid up to the level where the positive NPV projects actually become rare, right? So if the rate goes up, then the NPV of the projects go down, right? So that's the reasoning. Okay. Now, although the concept is hopefully by now pretty clear and you can see that it's pretty simple, the problem is that if you try to apply it to real world, there are kind of like a lot of difficulties, right? So let us just kind of like list down what are some of these difficulties. So one difficulty that is going to be there is that, this is based on you knowing actually what are the cash inflows and outflows in the future completely accurately, right? So this is typically an information that is not going to be that well available to you. Again, you have to use the discount factor. So far, we have been dealing with this constant discount factor. In the future, you'll see that we'll also talk about different interest rates. But then too, you need to kind of like take into account that how do you kind of factor in this kind of like different discount factors, right? So what you need to do is you need to actually go out and estimate them, and this will make the problem more complicated than what it is, right? Where you are just given these inputs and then you are just kind of like applying it. The other difficulty is going to come in from the fact that we have always been working under this perfect market assumptions, right? However, those are also kind of violated in the world, right? So in the real world, you do have taxes, you do have transaction costs, which is this cost of buying and selling these different assets. You do have disagreements, which means that the amount for which you can sell the asset may not be necessarily what you think is the valuation of the asset, right? And you do have buyers and sellers with market power, right? So all of these factors are kind of important in the real world, and we'll deal some of these complications later on when we study imperfect markets. But you'll see that even in imperfect markets, the NPV is going to be an important benchmark when to think about how to decide about whether to take up a project or not, right? But one difference that's going to come is that you may have other rules that are going to provide you additional useful information that is not present in the NPV. And then you may also have other rules actually recommending alternative project choices, right? But that's a complication when we'll discuss in more details once we have understood better how to incorporate uncertainty in our framework, as well as how to relax some of these assumptions of perfect market, right? So that's coming up in later weeks. Okay, so let's kind of like think about a couple of applications related to NPV. Okay, this will also help us understand better what exactly are the implications of perfect capital market, these assumptions that we are making. So one question is that imagine that you have a perfect capital market and you are deciding whether you should take up a project or not. In this case, should one's preference about the timing of the cash flows matter? Right? This seems like a very abstract question, so let me break it out into a simple example. So imagine that you have two people, person A and person B. Now, person A is very impatient. Person A wants as much money as possible today, but does not want to incur an upfront expense, which is involved in this project, right? So typically projects have some cost that you have to incur and then money comes up later on, right? But because person A is interested in having as much money as possible today, person A is hesitant in kind of putting in the money here today, giving up money now so as to get more money in the future, right? So then should this person actually give up positive NPV project if such a project is available? That's the question, right? Person B, on the other hand, is a person who wants to defer consumption as much as possible and wants to just save for the future, right? So this person is more interested in maximizing consumption in the future and would rather kind of like not spend on anything, right? So you can see that these two persons have like very different preferences in terms of how much to consume and how much to save, right? The question is, suppose you give them a positive NPV project and you ask them, okay, are you interested in investing in this project or not? Would the two people actually agree on, okay, what to do with the project, right? Accept it or reject it? Or would these people come up with a different answer to this question based on their different preferences about consumption, right? So let's take an example just to make things a bit more concrete. So imagine that you have got 150 units cash in hand, right? And you have got exclusive access to a project that costs 100 units today and it returns 200 units next year. Okay. And the interest rate that is prevailing in the economy is 10%. So if you do the calculation for this project, so basically the NPV is minus 100 plus 200 divided by 1.1. So you'll see that it's a positive NPV project, right? So our prescription based on what we have discussed is that you should take up the project, right? But now we are exclusively kind of like bringing in this thing that you have got two different people with two different preferences, right? One person wants to consume as much as possible today, the other person wants to consume as much as possible in the future, right? Are these two people also going to agree to this? Okay, so let's first do the analysis from person A's perspective. So would person A take up this project? So imagine that person A actually goes ahead and takes up the project. So what it would mean is that out of the 150 units of cash that this person has, this person has to put in 100 units of cash into this project, right? Okay, suppose the person does that, then what does this person have? So the person basically has, as a result, a project which is going to pay out 200 next year, right? So, but remember, this person wants to maximize consumption as much as possible today, right? The person does not want to wait till the next period to get hold of this 200 that's coming up. So what can this person do? Well, this person can go out and actually sell this project in a competitive market, right? After having incurred a cost of 100. Why does this person need to be the one to incur the cost of 100? Remember, this person is the one who had exclusive access. So the person has already incurred the cost and is now planning to sell it. So what would the price that this person get? Well, this is basically you are selling in the market, basically rights to having 200 next period, right? What will be the valuation of that 200 next year in terms of the economy today? So you've got basically a 10% interest rate. So 200 in the next period is equivalent to 200 divided by 1.1 today, right? So that's approximately equal to 181.82. Now, if you sell it for 181.82, what is the total amount of money that you actually have today? So you have this 181.82 that you actually had, right? And then you had out of the 150 that you had to use up 100 to actually invest in this project. So you have to subtract out that 100. And then you kind of like are left with basically 50 on top of this 181.82, right? So you end up with a total amount of money, which is 231.82 today, right? Now, notice this is definitely much more than one would have got if one had just consumed this 150 cash at hand that had, right? So person A, by actually investing in this project and later on then selling this project today itself, is actually getting more money, 231.82, compared to what one would have got if one had consumed this 150 cash, right? So even though this project involves an upfront cost, right? Person A should still actually be willing to do that because the returns that it is getting in terms of selling it today is more than compensating this amount that one has to actually incur in the cost. Okay. What about person B? So again, we are back in the same scenario. So you have got 150 units cash on hand and you have got exclusive access to a project that costs 100 and returns 200. Return interest rate is 10%. Person B wants to defer consumption and save for the future. Would person B take up the project? Well, let's see what happens. So there are two options, right? Either you do not take up the project or you take up the project. If you do not take up the project, then you have got this 150 units cash in hand. You can put it in the bank or something and get an interest rate of 10%, right? If you do, on the other hand, put in the money, then you have only 50 units which you would be able to put in the bank and the 100 units are going to be in the project, right? So if you do take up the project, you're going to get 200. Okay. So remember 200 is the payoff from this project in the next period. And you have got basically only 50 units that you can put in the bank, right? Because Out of the remaining, so total of 150 that you started out with, you had to use 100 to actually invest in this project. So you're going to get next period 15 to 1.1, right? So that's 55. So the total amount that you're going to get next year is 255. And if you compare with, suppose this person had not actually invested in the project, then the person had just 150 and that he had put in the bank, he would have got 165, right? So 255 is definitely more than 165. And so therefore the person should actually also take up this project, right? So that's the conclusion, right? So what is the lesson of this example? So regardless of when one wants the cash, which is actually a consumption decision, right? Do you want to consume today or do you want to consume more in the future? This does not matter, right? When you're deciding about when to take up the project or not, right? So this again goes back to all the information is actually available in the NPV, right? So you're better off again taking all positive NPV projects, which is an investment decision, and you should use the capital market to shift consumption to when one wants it, right? So notice that person A, because this person wanted to have most consumption today, actually use the capital market to sell the project and get money for it today. And person B, on the other hand, wanted to actually get money in the future. So then person B actually put some of his money in the project, which resulted in higher earnings later on, and you use the remaining one to kind of like keep it, right? So what it says is that if you have got perfect markets, then consumption decisions should not influence investment decisions. You should think of these two separately. Investment decisions are where you use the NPV criteria, for example, and consumption decisions are something that you can use to kind of like the capital market combined with the investments that you make to shift consumption to when one wants it. So term is what is known as separation of decisions, and this is an important aspect of perfect markets. Now we'll see that when we study imperfect markets, this separation of decision property that we just studied does not necessarily hold, because you might face different borrowing and lending interest rates. And at that point, different people may actually kind of like end up with different decisions based on one's consumption preferences. Okay. All right. So let's look at another application. Now, as I mentioned that one important thing that you need in order to actually use the NPV criteria is that you need to know the cash flows and the interest rates, right? Now, typically, it's practically impossible to get all these inputs perfectly correct, right? So one question might be that suppose you have an opportunity of putting in effort to improve your estimate of cash flows, or to put in effort in terms of improving your estimate of interest rate or the cost of capital. Which one is actually more worth doing, right? Is it worse to commit an error in estimating cash flows, or is it worse to commit an error in estimating cost of capital? So to answer this, we'll do as what is known as a scenario analysis, right? So what that means is that we are going to consider a simple project, and we'll see that how, if we make changes in estimates, how would that lead to changes in our kind of like present value? So how much of an error will we be making, and we want to compare these things, right? Now, this is also very useful for managers who need to learn how sensitive their estimated value is to actually whatever the different possible outcomes that can happen, right? So typically you want to make a decision which is robust to your estimates of some underlying parameters which you may not know for sure, right? And so therefore this method is also known as sensitivity analysis, right? So let's take a look at an example of how it works, first by looking at a short-term project and then by looking at a long-term project. So in terms of a short-term project, assume that you have a project that is going to pay off 200 next year, okay? And the correct interest rate is actually 8%, okay? So in that, we can actually calculate what the correct present value is. So this is given by 200 divided by 8%. And if you do the approximation, this is around 185.19. So this is the actual correct value, which you could have computed if you had information about the correct cash flow, which is 200, and the correct interest rate, which is 8%. Now, we are going to consider two different scenarios. One where you are off with your estimate of the cash flow by 10%. So basically, instead of 200, you imagine that the actual cash flow is going to be 220, which is 10% more than the 200. So what's the error as a result of this? So if you now compute the present value based on your incorrect estimates, right? So 220 divided by 1 plus 8%. So that's around 233.70, right? So this difference you can actually compute, and you can see that this is basically going to be 10% of this actual correct present value, right? So you're off by 10% in terms of your actual calculation, right? Okay. What would have been the case if instead of being off by 10% about the cash flow, you were actually off by 10% about the cost of capital? So what that means is that suppose that instead of the 8%, which is the correct interest rate, you're thought that the interest rate that you should discount by is 8.8%. Okay. Now, if you do the calculation, so then your incorrect measure of present value is 200 divided by 1 plus 8.8%. And that's actually approximately equal to 183.82. Okay. So what that means is that the difference between the true value and the incorrect estimate, remember the true value is 185.19 and your estimate is 183.82, is actually less than 2, right? Compared to the previous case where the difference was more than 17, right? So this is actually going to lead to an error of around 1% of the actual present value, right? So the lesson is that in this example, what it taught us is that for short-term projects, errors in estimating correct interest rates are actually less problematic in computing NPV than are errors in estimating future cash flows. So if you have got short-term projects, you should put in more effort in making sure that your estimates of future cash flows are more precise than actually your estimates in terms of the interest rates, because they matter less in terms of the total error. Okay. What about if you instead you have a long-term project, right? So we consider the same project as before. So you have got 200, that is the payoff, and the interest rate is 8% per year. The only difference is that now imagine that the payoff is happening in 30 years rather than in 1 year's time. So now you can go ahead and again compute the correct present value. So this is 200 divided by 1 plus 8% to the power 30. So that's around 19.88, right? And now if you make a 10% error in cash flow, so that instead of 200, you are again doing 220, you can show that this is going to lead to a correct computed present value of 21.86. So you can see that the difference is much kind of the absolute value of difference is lower, but the percentage wise, it's still like the 10%, right? Okay. What happens if instead now you make a 10% error in the cost of capital? Well, in this case, you are going to again assume 8.8% instead of 8%, but now you're multiplying it to the power 30, right? And you can see that now the absolute error is much larger here, right? So you end up with an estimate of 15.93, which is much lower than 19.88, than 21.86 was compared to 19.88, right? So what you get here is that even here you were making 10% error, but here you are making a higher percentage error, right? So the lesson is that if you have got long-term projects, both cash flow errors and cost of capital errors are important, right? Cash flow errors because of the same reason as before, but cost of capital errors now are compounded because you are actually, for instance, here taking it to the power of 30, right? Of course, one thing to keep in mind whenever you're all of this discussion is that it's typically much more difficult to actually estimate the faraway future cash flows than it is to estimate the faraway discount rates, right? Why? Because typically, there are this like different instruments that are kind of like available in terms of trying to elicit what's the cost of capital that is required for people to uh, kind of put in this money in this like long-term projects. However, it's still very hard to kind of like come up with a good estimate of, how much is this project going to actually pay off 30 years in the future, right? So this is one caveat to keep in our mind when we say that even though both are important, typically trying to reduce cash flow errors is going to be a much more difficult task than trying to reduce errors in the cost of capital estimation when we are discussing long-term projects.